Okay, so calculate the area of a trapezium, shown above, giving you units in your answer. Now, trapezium, they actually give you the formula in the exam, in the formula sheet, at the start of the paper. Okay, so you don't need to memorize it as such, but it's good to be acquainted to it so you know exactly how it works. Okay, don't just turn up to the exam thinking, oh, formula's there, so I don't need to practice it. The more you practice, the more comfortable you feel with it, and the more you recognize as well. Here the question is quite generous. They've actually said that it's a trapezium, but usually they won't say that, right? Especially in numeracy exam, they won't specify it's a trapezium. You've got to recognize it. How do we recognize it? Well, with a trapezium, you've got one pair of parallel sides, okay? You notice here, this side is parallel to this side. So you've got the arrows there, yeah, to prove that they're going in the same direction. That's what parallel means, going in the same direction. The sides sort of adjacent to it here, these ones, are not going in the same direction, okay? One's skewing off that way, and one is sort of vertical, okay? So they're not parallel. That doesn't matter. It doesn't really matter about those two sides, okay? Point is, these two sides are parallel. If we've got one set of parallel sides, okay, one pair, use the trapezium formula. And in terms of the trapezium formula, your A and your B are these two values here, the sides that are parallel, okay? And it doesn't matter, you can call that B if you want to do that A. It's your choice. And the H is the height between them. Now the height between them has got to be the perpendicular distance between them. So what I mean by perpendicular, if I was to draw a line there, that line would have to be right angles, okay? That would be the perpendicular distance, the straight distance, the most direct route, if you like, okay? You know, if you look at that distance there, that isn't the most direct route, that's going at an angle, right? So that would be no good. We need that distance there, okay, the direct route. And what's good, of course, about this is that they actually tell you that this is 9 here, and that's a right angle, so this has got to be the same, isn't it? That's got to be 9. So put it into the formula, okay? You've got half to start with. In the bracket then, your A and your B, these two values, 12.2 plus 14.3. And then I'm going to write times, okay? Because there's no times written there, but I will write times because there's a term after the bracket, all right? And if it's after the bracket, calculator doesn't like it unless you write times, okay? So we are timesing now because there's nothing between them. Times by the height between them, which of course we established as 9 centimeters. So I can do this all in one go on my calculator. So if I put in 1/2, so press the fraction button, 1, so replay button down, 2 across, press the replay button across, then open bracket, 12.2 plus 14.3, close bracket, and then times by 9, and I get my answer to be that. So if I press the SD button, I get 119.25 centimeters squared, okay? It says give the units in your answer notice, okay? So that's important to look out for things like that. You should be writing units down anyway, but it specifies it particularly there, okay? So if you don't do it, you lose a mark. Centimeter squared, of course, for area.